Hello friends, welcome to this new lesson on expansion of solids. By the end of this lesson, you will be able to understand the effects of heat, distinguish between heat and temperature, understand problems associated with expansion, understand that different materials expand at different rates, and finally comprehend the use of expansion. Let's see what effects heat has on a substance. When a substance is heated, it increases in size. We say the substance expands. This process is called expansion. When a substance is cooled, it decreases in size. We say the substance contracts. This process is called contraction. Have you ever wondered if temperature and heat are the same? No, they are not the same, because a spoonful of boiling water will have less heat energy than a beaker of boiling water. Let's carry out a little experiment. This experiment is called the ball and ring experiment. Predict what happens when we heat the metal ball for approximately 5 minutes to a high temperature. Note that before heating, the metal ball is able to go through the ring. After heating for approximately 5 minutes, the metal ball expands and no longer passes through the ring. Now, predict what happens when we cool the metal ball. The temperature of the metal ball will decrease. Therefore, the metal ball contracts and its size will diminish. Eventually, it will pass through the metal ring again. In this slide, we are going to have a look at the problems caused by expansion. Too much expansion on a very hot day can cause roads or pavements to crack, or tiles to pop out. To solve this problem, the tiles or pavements and walls are laid with expansion gaps. Can you guess what happens to railway tracks during a very hot day? Of course, it expands. In certain circumstances, the expansion causes distortion in the railway lines. This is why expansion gaps are essential. Telephone wires and cables raised on poles contract in cold weather and become taut. They may even snap To prevent this, they are loosely attached from pole to pole to allow for contraction. Let's now have a look at the uses of expansion. The first one is the rivets. Rivets are used to join two steel plates together. When warm enough, the rivet is put into position. It is then hammered into a head and allowed to cool. The contraction on cooling helps to tighten the steel plates together. Do you think that all types of materials expand at the same rate? Actually, different materials expand at different rates. For example, brass expands more rapidly than aluminium. If we rivet a strip of copper and a strip of iron together, we have what is called a bimetallic strip. The copper expands more than the iron when heated. Thus, when heated, the strip bends with the copper on the outside of the curve. When cooled down, the copper contracts more than the iron. Thus, the strip bends with the iron on the outside of the curve. A thermostat keeps temperature constant. It is found in ovens and refrigerators to keep the temperature hot and cold respectively. In an oven, heating takes place when the current is flowing. When the temperature is too high, the strip bends away to break the contact and current eventually no longer flows. In a refrigerator, cooling takes place when the current is flowing. When the temperature is too low, the strip bends away to break the contact and current stops flowing. So kids, the things to remember on thermal expansion of solids are: heat and temperature are two different quantities. Expansion and contraction may cause some problems. And finally, the thermostat can be used as a switch in an oven or refrigerator. That's all for today's lesson, friends. See you next time for more fun.